Okay, folks, hopefully you just watched the video where we talked about concentration conceptually, talked about solvent and solute and concentrated versus dilute. Now it's time to jump into the actual math and do some calculations of molarity directly and then using the dilution equation as well. So, molarity, what is it? Well, molarity is, if you have a number and it has a capital M behind it, we say that as the molarity of whatever the solute is you're concerned about. And what that really is that same number, that is the number of moles of that solute per 1 liter of solution. So if you were to say that it is 2.00 moles of HCl per 1 liter of solution, SOLN is the accepted abbreviation for solution, and I will use it all the time, just warning you. That is the same as saying it is 2.00 capital M molar HCl, meaning this capital M represents the moles per liter of solution. And then whatever the solute of interest is, that guy is right after that capital M. So watch your sig figs. Make sure that you have the proper number with a proper number of sig figs. You have the unit correct, either writing out moles over 1 liter solution or using the capital M. We're going to prefer you use the capital M. Make sure you can interpret it and use it properly. And then also make sure that you have the identifier for which solute you're referring to, because you can have a solution that has multiple solutes in it, and you'll need to give me the concentration of each one. So you need to know which one in particular you're referring to. All right, let's do some simple problems up front here. What is the molarity of a solution prepared by taking 1.22 grams of sodium chloride in a total volume of 100 milliliters? So the amount of solute is 1.22 grams of sodium chloride, and the total volume of solution is 100 milliliters. So if you consider that all concentration is amount of solute per unit volume, you can already write this as a concentration unit simply by saying 1.22 grams of NaCl is dissolved in 100.0 milliliters of solution. Now, it wants molarity. Molarity we know to be moles per liter. So we have two jobs. We need to get grams to moles on top, and we need to get milliliters to liters on bottom. You can do these in whichever order you want. Does not matter, as long as you do both steps. So I'm going to first attack the numerator. So I need grams of NaCl to become moles of NaCl. I write that as one step because I know I get that information from the periodic table that tells me how many grams 1 mole of sodium chloride would be. So 1 mole of NaCl, if I run off to the periodic table and I add up 1 sodium and 1 chlorine, that comes up to 58.44 grams. So in doing that step, I'll be getting rid of grams of sodium chloride, and I'll have moles of sodium chloride in the numerator, which is what I need for molarity. So now let's take care of the denominator. In the denominator, I have milliliters currently. I need that to become liters. So I need milliliters of solution to become liters of solution. And that relationship is just a metric conversion. You're supposed to know what milli means. Milli is a unit size smaller than base, and it stands for 1,000. So there's 1,000 of the small unit size milli for every one of the base. In doing that step, milliliters of solution will cancel, and I'll be left with liters of solution on the bottom. So when I do this math, what I'm going to be left with is I'm going to do the 1.22 times 1 times 1,000, get that answer, divide that by, I'm going to open parentheses if I'm using my calculator correctly, and do 100 times 58.44, close parentheses, hit enter again, and I'm going to get a value of 0.209, and the units will be moles of NaCl over 1 liter of solution, which we can write as 0.209 capital M NaCl. All right, so that's an example of when you're given the amount of solute and the total volume of solution, and your job is just to simply put amount of solute over volume and get to the right units to have molarity, which is moles per liter. That's a common problem. Another common problem is I want to go into the lab and I want to make a solution that has this molarity, and I want to make that much of it. So how much of the solute do I need to go weigh out and then dissolve in water and bring that total volume up to my desired volume? How many grams of sodium hydroxide are required to prepare 1.5 liters of 2.00 molar sodium hydroxide solution? So we need to make this much of a solution that's that many moles per liter in sodium hydroxide. And we're going to need to know how many grams of sodium hydroxide I need to go get in order to do that. So you've got liters and you've got molarity, molarity being moles per liter. Hopefully you see that if I have liters and I have moles per liter, that liters would cancel if I set them up this way and give me moles. And that is exactly how we're going to go about it, because once we get to moles, we know that we can use the periodic table to go from moles to grams. So that's going to be our logic that we're going to use in doing this problem. Start with that 1 unit volume, use the molarity as a conversion factor. So I have 1.5 liters of solution. The concentration of that is 2.00 moles NaOH for every 1 liter of solution. So if I did that math and stopped, it would tell me how many moles of sodium hydroxide I needed. But I want to actually weigh this out on a balance. I need grams. So liters of solution would cancel. I would be in moles at this point, but I want to go a step further. And I want to go from moles of NaOH to grams of NaOH. I want to know how many grams I need to go weigh out in order to make this solution. So if you run to the periodic table, add 1 sodium, 1 oxygen, and 1 hydrogen with a 2 decimal point periodic table, you're going to end up with 40.00 grams per mole of sodium hydroxide. Units of moles of sodium hydroxide will cancel, and you're going to be left with only grams of sodium hydroxide as the unit for your answer, which is what it asked for in the problem, so you can feel good about that. And when you do that plug and chug, you started with only 2 sig figs in your 1.5. It's all multiplication and division, so you can only keep 2 sig figs in your answer. So it is 120 grams of sodium hydroxide.